Hi everyone, Assalamualaikum. In this video, we are going to continue with volume by washers. Okay, now we look at example 2 from previous semester papers. The shaded region in the figure below is bounded by the curve y equals to set x, the y-axis and the line y equals to 2. Using the washer method, find the volume of the revolution obtained when shaded region is revolved about the line x equals to 4. Okay, so this is curve y equals to set x. Okay, this is line y equals to 2. Okay, and this is y-axis. Okay, and then the axis of rotation is line x equals to 4. Okay, where is line x equals to 4? Okay, so first, okay, we need to find the intersection point. Okay, so that we can predict where's the line x equals to 4. Okay, to find the intersection point between curve y equals to set x and line y equals to 2, okay, we can equate set x equals to 2 from here. Okay, from y equals to 2 and y equals to set x. Okay, here is the intersection point. So we can equate because this is y and this is y. So we can equate set x equals to 2. Okay, then we can move set or square root here to right hand side. So we get 2 squared. Okay, then we get x equals to 4. Okay, means here x equals to 4. Okay, so this is the line x equals to 4. Okay, our axis of rotation. Okay, line x equals to 4 here. Okay, alright, after we find the axis of rotation here, okay, right, from here, this is vertical line. Okay, our axis of rotation. Okay, from volume by washer, if we have axis of rotation is a vertical line, okay, so we need to integrate with respect to y. Okay, when we integrate with respect to y, all must in terms of variable y. Okay, and to write variable y, we need to write x as a subject. Alright, so from here, we need to write x as a subject. Okay, we move square root here to left hand side, so we get y squared. So that's why we get x equals to y squared. Okay, now we get x as a subject. Alright, and then after rotation here, okay, we get this diagram. Okay, alright, from the given shaded region here, okay, and the axis of rotation here, there is a gap between the shaded region and the axis of rotation. So this is the gap. Okay, alright, if we have gap between the shaded region and the axis of rotation, means we will have hollow object, right? A washer is like a disc, but with a center hole cut out here. Okay, this is the hollow here. Okay, this is the solid diagram and this is the cross section of this diagram. Okay, from outside we see it looks like a cylinder, but actually inside here has a hole. Okay, and this is the shape of the hole. Right? Alright, from here, x equals to 4 is an axis of rotation. Okay. And the straight line here, which is y-axis here, or line x equals to 0, okay, is an outer curve or line. Okay. Alright, how we get x equals to 0 here? Okay. This is from x-axis. I mean y-axis. Okay. So y-axis in terms of equation of line, it is x equals to 0. Okay, so from here. Right, y-axis means line x equals to 0. And x-axis means line y equals to 0. Right? And this is inner curve. Okay, after we write x as a subject, so we get x equals to y squared. Right? This is outer, okay, and this is inner, okay, from the cross section of this diagram. Right? And this is outer radius R1 and this is inner radius R2. Okay. Right, after that, from this formula, we need to find the outer radius. Okay, outer radius equals to modulus outer curve or line minus axis of rotation. So our outer curve here, okay, we minus with axis of rotation here. Okay, and inner radius, okay, equals to modulus inner curve or line minus axis of rotation. Okay, from this formula, right? Right. Outer curve equals to outer curve. Outer radius equals to outer curve or line. Okay. Alright. So outer curve or line here is x equals to 0. Okay. So we replace by 0 here. Okay. Note that all equation we write x as a subject here. Okay. So that we can subtract. Okay. And then axis of rotation, okay, here is equals to 4. So we replace this. Okay. Then we get outer radius equals to negative 4 modulus. So outer radius equals to 4. Right? Then we need to find inner radius. Okay. Inner radius equals to inner curve or line. Okay. This is inner curve or line. Okay, we replace by y squared here. Minus axis of rotation. Okay, here. Okay. We replace by 4 here. Okay. Then we simplify, so we get inner radius equals to y squared minus 4. Right? So now we find outer radius and inner radius. Okay. From the previous slide, after the shaded region is revolved about the line x equals to 4, so we get this diagram. Okay. And this is hole cut out, okay, at the center. Okay. We have hollow here, okay, because there is a gap between the shaded region and the axis of rotation. Okay. And we get outer radius equals to 4. Inner radius equals to y squared minus 4. Alright. After we find the outer radius and the inner radius, so we can set up volume by Washer formula. Okay. So from volume by Washer equals to pi integration of outer radius squared minus inner radius squared. Okay. We need to separate the squared here. Okay. Alright. So we need to check our axis of rotation here. Okay, our axis of rotation is a vertical line. So using Washer method, when our axis of rotation is a vertical line, so we need to integrate with respect to y. Okay, and we need to use limit on y-axis. Okay, our lower limit y equals to 0 from here. Okay. And our upper limit y equals to 2 from here, right? And then we replace outer radius equals to 4, okay? And inner radius equals to y squared minus 4, okay? And then from here, under Washer method, or under this method, if the axis of rotation is parallel to y-axis, means it's a vertical line, so alter mass in terms of variable y, including lower and upper limit. Okay, mass on y-axis. Alright. So after that, we need to expand and simplify. Okay. So after we expand and simplify, we get this. Okay. Pi and then integrate from 0 to 16 and then minus y to the power of 4 minus 8y squared plus 16. Okay. And then from here, we simplify, so we get pi and then integration from 0 to 16 and then minus 16. So we get 0, no need to write. And then minus times y to the power of 4, so we get minus y to the power of 4. And then minus minus, we get positive 8y squared. Okay, so since this is positive sign, so we can put in front here, right? So after we get this, we can integrate with respect to y, right? So when we integrate, so we still have constant 8 here, and then we integrate y squared using power rule, so we get y cubed over 3, and then minus, when we integrate y to the power of 4, we get y to the power of 5 over 5. Okay, this is definite integral, so no plus c, but we need to write square bracket with lower and upper limit. And remember, after we integrate, no more integration sign, right? Alright, after that, we need to replace the upper limit into variable y, and then in between must minus, and then we replace lower limit 0 into variable y here. Okay, 0 to the power of any values equals to 0 and times any values equals to 0. That's why we get 0 here. Okay, and after that we simplify, so we get the final answer equals to 224 over 15 pi units cube. Cube here is for volume. Alright, we can check the final answer using Symbolab. Okay, so from this point, okay, when we set up the formula, when we substitute the outer radius and the inner radius here, so we can check using Symbolab. Okay, integrate from 0 to 2, and then 4 squared minus y squared minus 4, and then bracket square here. Okay, after we press enter, we get 224 pi over 15 here. Okay, and the answer for volume always positive. Okay, if we get negative value, maybe we make mistake when we set up the formula, or maybe we make mistake when we integrate, or maybe we make mistake when we substitute the lower and upper limit. Okay, alright, so from the final answer here, we just leave our answer in fraction and pi, okay, because it's more accurate compared to when we leave in decimal. Alright, so this is the complete solution. Okay, got it? This is the final answer. Okay, coming up next, more examples for volume by washers. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.